Everyone, it's been an amazing 4 days, and Phil and I flew here from London about 2 days ago. We were part of Cohort 4 in October, and Stu and everyone at Picnic are so welcoming. They're such a great community of people to actually be involved with that we decided to come back again. We've been involved with the Filecoin ecosystem for about a year now. Initially, we were focused on just building software, but we're now sort of focused also on getting our own hardware. We are big believers in decentralized cloud as well, but we think that there are key missing elements in the story of decentralized cloud today. And our raison d'etre is really privacy. It's encryption, it's privacy, and we think those core primitives are what will really take decentralized cloud to the next level. And we are building tools that plug in those gaps in the ecosystem today. No worries. Great. So, yeah, who are we and what's our story? So, Phil and I both are co-founders, and we started about 4 years ago as a fintech, about in 2019. And back then, I guess Filecoin was in its infancy, and we were really focused on optimizing debt capital markets, which is a very traditional and archaic industry. And we were creating private networks to allow banks and asset managers to sort of issue assets on the ledger and allow them to trade. However, we were not able to really scale this platform. And the biggest reason, the biggest shortcoming for our failure back in 2019 was that major institutions didn't want to trust us with their data, with their sensitive data. Even though we were following all best practices and all of our data pipelines were fully secure, the data was encrypted, our workload was on AWS, on the cloud. And we were trying to aggregate data from different asset managers into this one mosaic. But most of our clients that we pitched to said that, wait on, you're a startup who's actually aggregating data from these distinct sources, and you could just sell this to AWS or to some other bank down the street, and you could pretty much ruin our business model with this. So we started to really think of what are solutions around these kind of challenges where you have data from distinct sources, you want to compute on it, and all of this data is sensitive. How do you really define an infrastructure where it's truly trustless, and even you as a software vendor or provider cannot physically actually use the data for purposes it's not meant to be used for? And over the course of our research, we started to look at different privacy technologies. About in 2019-20, I think all of the major Web2 cloud vendors started to push something called confidential VMs. And in fact, Mark Russinovich, who's the CTO of Azure, he bet big on something called trusted execution environments. These are specialized regions of memory in Intel and AMD CPUs that basically operate on encrypted data. Not only do they operate on encrypted data, you can actually verify with strong guarantees how the data is used. So you can configure your workload and actually get proofs. And so we really started to look at this technology as a means to solve this trust gap. And that's what we're focused on now. We think that today with decentralized cloud, compute is the next big thing. And it's everyone in this room, I think, agrees with me. And Picnic, Filecoin, everyone is pushing towards creating products that really allow for the data stored on these massive storage to be actually used. You can't just store data. You have to, as part of the cloud stack, you have to be able to run your workload on the data as well. And there are several initiatives like Bakiliao, who are a part of Protocol Labs, an amazing team of engineers who are working on creating a job definition and workload sort of manager for data on IPFS. And we're sort of working with them to make that workload and job definition actually execute on trusted execution environments. So yeah, I sort of jumped ahead and talked a bit about what we're building, but yeah, that's us. We have a team of 3 developers based out of India. The 2 of us are based out of the UK. And yeah, we're really focused on getting compute and privacy as a core primitive in this ecosystem. So yeah, why would an organization today choose the major Web2 CSP over Filecoin? Even though Filecoin is so cheap, like what is really preventing a big enterprise from shifting their workloads to Filecoin? And there are twofold, the answer is twofold. There are two key things that actually prevent most enterprises to switch. And this is our thesis, so obviously it's something worth debating, but we think that functionality today is lacking. And everyone knows this, that Filecoin is very good for archival storage, but does not offer hot storage and really cannot replace the backends of most performant applications. So it's not really suited for those, like the core workloads that any enterprise wants to run. And that's why most of the use cases today are around research institutions that are archiving their data. But we think that this gap will naturally sort of reduce in the coming months. In fact, Filecoin are working on Saturn, which is a distributed CDN, to get data quicker to the client. And there's other efforts in the ecosystem with local IPFS clusters serving as hot storage for data. But notwithstanding this, we think that there's one other element that's missing as well, beyond just functionality, and that is trust. And if you're a big CIO or CTO who's looking at optimizing your cloud costs, you look at Filecoin and you think, okay, this is an amazing technology, it's really cheap, but how do I really trust that my data over here will be secure? This network's public. I don't have really any ways to partition my data to enforce identity-based rules. There's no IAM-based policy management. So how does such a CTO really think around this issue? And I think this is the real key point that really makes most organizations not adopt Filecoin today, beyond just the functionality bit. And this trust barrier needs to be solved for any kind of meaningful adoption by enterprises of Filecoin. This is the hard truth, and I think that's why Phil and I are building this solution. We think that introducing encryption, introducing compute over encrypted data is really the way to create this layer of trust that is truly not dependent on NDAs or just legal frameworks, but it's actually enforceable by code. And that's really how you want to have trust. It should be a trustless system where there's no middleman. It's truly decentralized. So yeah, that's our core thesis, that data privacy is the key answer to reduce that trust barrier. There are other key sort of tailwinds towards the problem we're trying to address. And I won't belabor a lot on this because we're all in this room very well aware of the cloud costs and Elon Musk firing half of Twitter to try to optimize his cloud costs and all of that. I mean, we live in the world where every company is trying to grapple with this reality. But yeah, privacy is a big concern that's never going to go away. No enterprise will stop thinking about privacy. In fact, it is becoming more and more of a theme with every discussion, and most enterprise architects, even with Web2 cloud, really want these strong guarantees. So what's our solution, and how do we really make Filecoin become this trustless, data privacy-oriented solution? So we have three components in our decentralized cloud stack. Starting with storage, obviously we leverage Filecoin. What we've created is a encryption and key management tool. And the key management part of it is quite crucial. Today, if you want to encrypt data, you want to custody your keys in something like an HSM or in a software-based key management system that's maybe hosted by Amazon. But if you think about it, Amazon or any host of this key management service truly has access to your encryption keys. They have your private keys. If they know where the data is, they can go and decrypt it, and your data is really lost, and it's out of your hands where it goes. So what you really need is a robust solution that allows you to, in a performant way, encrypt your data, allows you to manage your metadata related to the encryption, and then the key that you use to encrypt the data should be sharded and actually custodied in a non-custodial, decentralized KMS. And that's what we've built, basically. we're leveraging a technology called Torus, which is which basically allows you to split your private keys into 3 parts. One of the parts is linked with your OAuth identity. The second part is on a device share, and the third part is distributed in a network of about 16 nodes. You can lose one part of the key and still recover the entire private key. And I think this is quite groundbreaking because non-custodial KMSs basically reduce the headache on any enterprise to be able to manage their keys, and it gives them a sense of security that they can actually lose a part of it and still recover the data. And for anyone to be able to reconstruct the key is impossible, because you really need that OAuth part of it to reconstruct the key. So that's what we've created for Filecoin. It's an encryption and storage tool with this decentralized KMS. The second part is actually what I'm most passionate about, which is the privacy-enabled compute. And I've already talked about TEs a bit, but in the slides following, I'll go into more detail. But bear in mind that we're building this privacy-enhanced compute solution as well. The third part of any cloud stack is you have the data stored, you've done some analysis on it, but then you want to share that analysis and you want to really monetize it. You want to maybe even collaborate with a third party. And for that, you need a tool which allows you to collaborate. And we think data DAOs or unions are actually the way to achieve that collaboration. So that is something we will look to build in the future. We know that there are some other efforts in the ecosystem, and we are very open to collaborating with those efforts as well. But we think the ultimate manifestation of decentralized cloud is a layer where people are hosting their data, they're computing on it, and they're able to collaborate on it and run joint analysis on it. I think that will be the true sort of endpoint of where Filecoin goes. So this is sort of a split of what our offerings are. I've already touched upon the encryption tools on the top left. That is open source, and it's actually live today. You can go to our GitHub. I can share the link with you. You can start using it today. We use S3 as a means to onboard data onto Filecoin, where the client can actually generate CAR files from their encrypted data, and then go through the usual deal-making mechanism for the CAR files. For the compute, we're building an add-on for Bacalhau, which is the open source Filecoin product for compute. And we're basically enabling the execution of the jobs inside a trusted execution environment, thus enabling compute on encrypted data. This is sort of how the secret works. The secret sauce behind our tool. It's a bit detailed. It's an architecture diagram, and I know this room is not full of the technical audience, but the key takeaways from here are that we use best-in-class Web2-based encryption techniques. Envelope encryption basically allows you to generate data encryption keys that are unique for each file and wrap them with a key encryption key. The data encryption keys are AES-256 GCM, and the key encryption key is an elliptic curve private-public key pair. And that key encryption key basically unlocks all of the metadata that maps your CIDs to the data encryption keys. And our solution basically lets you manage that metadata and custody the key encryption key. Moving on to compute. So I've already touched on how our storage solution works and the encryption solution works. So the next part is the compute. And this is a slide I literally just made yesterday, so it's not very well formatted, but I've been in the past few days really thinking on if there were to be a compute framework for clients to be able to use their data on Filecoin, what would be the considerations? What would be the different compute types that they would potentially run into? So starting with the right-hand side, this is the quadrant that I sort of came up with. And the two sort of axes, the vertical axis is whether the data is encrypted or not. And that's a key consideration, because if the data is encrypted, you have to have specialized hardware to run the compute. If the data is unencrypted, you can use general CPUs. The other horizontal axis is whether the compute itself is general compute that just can run on CPUs, or does it require GPUs? Is it like an AI-based, machine learning-based workload? And with that, I was able to map what kind of hardware would map to what specific kind of workload or compute type. And on the top left, It's generalized compute on unencrypted data, and EPIC CPUs are quite tuned to run these kind of workloads. And in fact, like most SPs have investment already into EPIC CPUs. So that's really good news because you don't really need to invest additional money to run this compute. You already have hardware. If you're following the reference architecture that Picnic has, you already would have the hardware to be able to run this compute. On the top right is compute on GPU compute on unencrypted data. And for this, you would need RTX or similar series GPUs that have CUDA cores that can run machine learning workloads. And again, good news that PC1 workers, PC2 workers, all of these different reference implementations from Picnic's architecture, they all usually have GPUs as well. So again, you could possibly run compute on such compute as well. Things get interesting with encrypted data, though, at the bottom. And that's where you need specialized sort of firmware to sort of unlock a feature of AMD EPIC, which is called AMD SEV, Secure Encrypted Virtualization, which is basically the TEE technology of AMD. And I'm spitting out a lot of acronyms, so just like, if you have questions later on, I'm happy to walk through like what that means. But basically, this is what AMD's technology is to allow you to compute on encrypted data. And again, good news that most EPIC CPUs, starting from Rome and Milan and Genoa, all have AMD SEV as a component that's already there. So all you need is effectively firmware that can allow you to access that and run the workloads. The bottom right is a future state. It's basically you're able to run like machine learning workloads on encrypted data, and it's like a GPU enclave. And NVIDIA have come up with a GPU enclave called Hopper H100. That's their top line GPU, and it's very expensive. And I think there's not even a need for it today. And I think the time for that will come maybe 5 years in the future. I've taken a lot of time on this slide, so I'll quickly go through the left part of it. Thinking of compute, I think the key focus has to be on the client and how the workload is defined, whether the data is encrypted or not, whether the data is sealed or not. And that is actually quite troublesome, because if the data is sealed, you have to unseal the data and then be able to like really extract the part of the data that the user wants to run the compute on. So all these considerations have to be kept in mind. What runtimes does the workload support? Like, are we defining the workloads in Docker? Are they WASM-based? Are they like simple function as a service kind of workloads? So all these things are like different, and there's no truly right answer, because based on the use case, you can have like different kind of runtimes as well. Yeah, I think I'll skip over the hardware and the usability, but revenue. Obviously, we all want to make money out of this, and how would you do that? The answer is that Phil as a token could be the mechanism to actually charge for the compute cycles, but Phil already has its incentives and sort of tokenomics optimized for storage. So I think having an independent compute token really would be the way that you would be able to incentivize compute providers the right way. You could also have traditional SaaS-based sort of charge for the compute cycles initially, but I think the end state would be a compute token. This is Juan's triangle. So Juan Benet, who created Filecoin, presented this during Phil Lisbon last year, and it's sort of like a triangle that almost shows you that compute has trade-offs, especially decentralized compute. And the trade-offs are privacy, verifiability, and performance. And TEs sort of are the best sort of suited to optimize on all three of those, and hence why we're using TEs as the means to run compute on encrypted data. There are other technologies like fully homomorphic encryption that's at the top, and that is sort of the holy grail in terms of a compute over encrypted data, but it is not performant today. It can only do basic arithmetic, and it cannot scale to meaningful workloads. So yeah, the bottom line is that TEs are the best solution today to run compute on encrypted data. And the good news is that most SPs own hardware that has TEs. And you need the right firmware and the right software kit to enable that. And that's what we're building, basically, as Encloud. Again, this is sort of our architecture for how we want to enable that TE-based privacy compute. I'm going to focus on some of the key aspects, which are the key policy manager, because it's all about who gets access to your private keys to decrypt the data. And in a decentralized compute setting, you could have a compute client that configures their workload. They define a policy on their key policy manager that basically would release the keys only to the right TE that's executing their workload. So the TE executor at the bottom would be able to produce an attestation that it is the right hardware enclave, it is running the right code that the user configured, and it can then send out a request to the key policy manager, get the private key, decrypt the data, run the compute, and post the outputs to IPFS. So yeah, I rushed through that slide and happy to get into details on that offline if anyone wants to get into a discussion on how exactly we're building that out. So what's our ask? And obviously, this community has full of storage providers and Filecoin builders over here. So we have an ask for both of them. For storage providers, we have our encryption and storage CLI. So we really want to partner with you guys to help you onboard these encrypted data sets and give this decentralized key management solution to your clients, help you get more business. And we also want to partner with storage providers to test out our T-enabled compute. So we're going to release this in Q1 of this year. And any SPs who are interested in partnering to test out this compute capability, we'd love to partner with you and build this out. If you're an app builder or a Filecoin user, you can already start using our storage CLI today. You can start storing your encrypted data onto Filecoin. And if you're looking to run your compute on encrypted data, we'll be launching our solution in Q1 of this year so that you can access and run compute on encrypted data sets. This is sort of oriented this is sort of our development pipeline over the next few months. And I think I've already touched on it, so I'm just going to go through this. We're obviously fundraising as well. So these are the investment terms for that. We already have Protocol Labs confirmed as our lead investor, so we have the right backing. And if there's any VCs or investors out there, happy to talk to you guys and talk about investment. So yeah, that's us. And any questions on all of the details, happy to answer now.